Hey, hello, and welcome to John Park's Workshop. It's me, John Park, and we are here, and we are ready to do this, right? Right. So let's get to it, shall we? First of all, I want to say hi to everyone over on Discord, because you are the people having the conversation. That's where it's at. So if you're wondering, if you're over on one of the other platforms watching on Twitch or YouTube or Periscope or wherever, Facebook, you're wondering where are all these people talking, it's probably over on Discord. So you can head on over to adafruit.it/Discord and you will find the conversation, including people waving. Hello, Steve Noreko, Andy C. Grover. Who else we have? Gary Z. Liz is with us today. Excellent. And I'll just pop over into the YouTube chat. We have a question from Sevi Alvarez. What are the odds I can meet with someone to talk about a project I'm working on with Adafruit Motor Shield? Well, I'll tell you what. There is, if you head on over to this right here, this is the Adafruit Discord. And right now I'm looking at the live stream chat, but there's a channel for project help. So if you've got a question about a project, you might want to head over to that channel, and it'll depend somewhat on what project you work on. You can also go to the CircuitPython help, the Arduino help, help with audio, help with 3D printing. There's a lot of different channels there, and you can probably ask your question there and get some help. That's one place to do it. So hope that answers your question, Sevi. Let me know if you have other questions. Anyone in YouTube, over on Discord as well, and we'll get them answered. How about that? All right, and related to that, if you have a project where you're looking to hire someone for some help, you may want to check out the Adafruit job board. That is at jobs.adafruit.com, and this is it right here. If you head on over, you'll find there are open positions here. Up at the top, you'll see this is search for jobs or search jobs, and you can look through here. You can scroll through and browse. You can search for some keywords. You can also check out the available for hire. So you may find someone in here who's got some of the skills in an area you're looking for, and you might want to get in touch with them about some project hire, full-time hire. There's really any option, any version of that you want to do. And it's free, so you can head there. It's not going to cost you anything. We're not going to spam you. You do have to sign up. I think you have to have a Adafruit account. Use your email to log in there and use that. So that's another avenue to go, depending on what you're looking for. It's jobs.adafruit.com. All right, let's see what else is going on. What's happening in the making world here in the Adafruit news? One thing I do every week, you may know, is on Tuesdays, right at this same time, so 1 o'clock Eastern, or Pacific time, 4 o'clock Eastern time, I have a show, which is JP's Product Pick of the Week. It looks something like that. It's a little bit bonkers. And every week I take a look at a product, a new or new-ish product, put it through its paces, talk about it a little bit, do a demo, and it lasts about 15 minutes generally speaking, and we have a big discount during the show. So you can usually get 50% off on the product while the show is being broadcast, so you don't want to miss that. And then I put together a little 1-minute recap of the product pick of the week. So this week it was a digital potentiometer, a logarithmic digital potentiometer. And here's me to tell you all about it. The DS1841 log digipot. This is fantastic for any time where you want to be able to change the volume using either software controls or some other non-mechanical sensor to adjust volumes. Then you want to introduce this into the mix. I've got a little clock radio, and I opened it up and I ran some wires to the internal volume potentiometer. And I have grafted the DS1841 into there. It's running over a Stemma QT cable to this Metro, which has CircuitPython running on it. It is the DS1841, and it is a great digital substitute for a mechanical potentiometer for audio applications. So go check that out. Of course, you can still get one now. It's going to be for the normal full price. In fact, here's the product page. I can show you where you can go if you're interested in finding out more. That's it right there. That's normally $5.95. We had it for half off during the show. So come on by again next week on next Tuesday and see what's next and maybe get a good discount on it. So that's the product pick of the week. Let's see, next up. Hey, Charles Burnett-Ford over in the chat. I'll bring that. Where's that chat? There's that chat. Look at all these people saying hey. Chilly, southeastern Pennsylvania, you're waving from. All right, well, it's snowy over there on the East Coast, right? We don't have any snow here in Southern California. Maybe up on the mountains we do, but not down here in the lowlands. All right, so next up, why don't we do a little Make Code Minute? Hey, how about that? The audio alert works. I appreciate that. Yeah, I'm getting all kinds of warnings. Thank you, everyone. I'll wait a second because that alarm sometimes goes off twice. And then I will start again. So, yeah, here you get to hear version 2. Here we go. You ready? For the Make Code Minute today, what I wanted to do was show you how inside of Make Code, using just a very few blocks, we can create an analog read for, in this case, a potentiometer, which will map to the neopixels on the Circuit Playground Express. So first, here's the demo. I've got this little breakout board for a potentiometer. It's a standard, I believe, 10K pot. And you can see here, as I turn the knob, we get the same response as I turn that on the which neopixels are lit on that Circuit Playground Express. So let's take a look at how is this done. It's actually so simple you may not even believe it. Let me leave that in the background there. I can bring this over. There we go. So you can still see it. Okay. So what you'll see here, looking at Make Code, is I decided to do this in as few blocks as I could think of doing it in. So I have one forever loop, and it just repeats the code inside of there. I have one block that turns all the neopixels off, just sets them all to black. And then a moment later, it sets the pixel color at 1 neopixel to red. And the one that it does is based on this little block here, which is a map block, which remaps some values. So it remaps the 0 to 1024, or roughly that. I've fudged it a little bit, to the neopixels number 9, which is that top right one, to neopixel 0. So that's how I map that same direction of turn here to the neopixels that are on the Circuit Playground Express based on the knob. And it repeats that forever. So it's very, very simple. We could do this other ways, but this way works really well. I think it's easy to understand, easy to explain. And this is the key block right here, this analog read pin A1. And that is the pin where I have the value of that potentiometer reading. It's acting as a voltage divider, so we get an analog value. And that is how you can map a potentiometer or other analog input on the Circuit Playground Express to the neopixel ring right inside of Make Code. And that is your Make Code Minute. And thank you for all of the attentive watchers and listeners who noticed that I left my audio off when I came back from the song there. Some days it goes perfectly. Other days I forget all about that knob. It's an important one. All right, now why don't we take a look at a Make Code arcade game pick of the week. This one is quite tremendous. It is a remake of Outrun, and it is by C. Darius. I got this on the Make Code Arcade Forum, which is at forum.makecode.com in the arcade channel. And here it is. C. Darius says, I love Outrun, and I used it as an inspiration for this JavaScript racing game. There's no need to say it. You're driving a Ferrari. All right, let's check it out. So I'm going to restart the game here. I don't know if you'll hear much audio as I play it here. I'm going to press the A button to accelerate, and look at this. Not only do we have these beautiful graphics, but we're going to have this track curving around here. You can accelerate and hit the brakes. Get going pretty fast, and I'm sure in a second here I'll crash terribly. Let's see if I can spin out into the, right into the ocean. So this is really tremendously done. It's all a JavaScript game. So if you hit the code, take a look at the code button at the top, you can take a look at the JavaScript code for this. You can see that it's comprised of a number of different pieces of code. So there's the car physics, there's the circuit, how that's drawn. There are some math elements. There is the physics of the car, the player's car assets. So it's a really fully featured game. There have been some other, whoa, it's making lots of noise. Let me close that one there. There have been some demos before that I've shown from Make Code, from the Make Code community, on doing similar types of things. I believe using either an approximation of the SNES Mode 7, where there's a tile that's being rotated and set into perspective, a sprite as the track. Also, sometimes raycasting is used. So, if you want, take a look at here. You can still take a look at the assets. This new, let's see. Oh no, you won't be able to do it through the asset browser. But if you look at the code itself, you can click on the little icons to take a look at. Turn off that volume there, to take a look at things like the background and the car and such. You can take a look at the animations and how those work. So that is my arcade game pick of the week. Really tremendous. One of the most impressive Make Code arcade games I've seen so far, and that is Outrun by C. Darius, or C. Darius. Go check it out. And that is my Make Code arcade game pick of the week. Can you believe that? The things that people are doing inside of Make Code. Wow. Really tremendous. So keep up the great work. That would be a fun one to put on a handheld as well. Put it on like a Pi Gamer or a Pi Badge. Play it. Keep it with you and play it wherever you are when you get bored. There's some people in the chat saying, remember those Commodore 64 games? Oh, someone said, where's Lars? I think Lars fell over. I don't know what he's doing. He might be taking a nap. All right, so let's see. Next up, I wanted to show you a little sort of work in progress project that I am working on. It's something I think I may have shown before just as a gear find report, but now I've actually started to turn it into something. So let me switch over to different camera view here. About like that, and let me move myself out of the way there. There's going to be a couple versions of me here. There we go. So maybe there. Oops. That'll work. Okay, stand by. Now let me head over here. So here's what's going on. This is so what I have here is I've got a laptop, and we can pretend that I'm working on editing a video, because very often I shoot footage and then I have to edit the video. I use a video editor called Premiere, but this would be relevant to pretty much any nonlinear video editor that you might use. Right now, just to demonstrate it, I just have a movie open inside of QuickTime, but the controls actually map the same. And so things that happen while you're editing is you're often looking for one very specific frame. And here you can see I'm using the arrow keys to tap between frames. So sometimes you're looking for a very specific frame to cut on, or you're looking for some motion. And you can drag a timeline with your cursor. So you can go in here and click and drag a timeline bar. You can use these controls. But something that makes this much, much easier is let me put these glasses away, is a shuttle and jog controller. So here you'll see when I turn this wheel, I am very finely adjusting which frame I'm looking at, and we can go real fast, we can go backwards a frame, and so if I find an exact frame there, I might then put a cut mark or a marker or something like that. Something else you'll often do is just play, enter the secret code, and stop playing or pause just by hitting the same button once and twice. And another thing you'll often do is want to sort of fast forward or rewind at different rates. So each time I hit a button, here I'm going to go backwards, and that's going at 1x, and 2x, and 3x, and 4x, and then I'll hit stop there, and then maybe I'll find that frame. So these are really typical controls that you'll use inside of a video editor, and having a dedicated piece of hardware for this is great. Now, the piece of hardware I'm using here is kind of the interesting part. You'll see here, this is something that I rescued from a closet of things that we were getting rid of when I worked at Disney Animation Studios. So this was used as a hardware controller for an animation disc playback unit. So it was a hard drive based unit, I think, but similar things were also used on like half-inch tape based units. This one I think was used on a hard drive playback device. And it's actually made by J.L. Cooper. They used to make this called, I think it's the MCS2. This one just happened to be special branded for Disney with some logos on there and a different controller for this option. It has little Mickey Mouse ears on there. But what's interesting about this is that this is not using a proprietary control scheme or a strange jack. This is actually using hardware MIDI. So it uses a classic DIN5 MIDI output. And so I plugged this into one of our little feather breakouts. I can zoom in here, and I might need to refocus. There we go. So you'll see this is the data cable coming out of the shuttle controller there, the hardware controller. I have it going into our Featherwing. That's a MIDI Featherwing, so it has an input and an output DIN5 connector. And then I have this on a feather doubler, and I'm running a Feather NRF 52840 because I needed some decent horsepower to decode and then resend these messages. And what I'm doing is I'm taking those messages, which are either MIDI machine control, which is SysX messages, or standard MIDI controls. There's some subtleties about what you can do with the two different types of signal that it sends out all the time. But I'm reading those in, and then I'm writing them out as HID USB. So I'm essentially sending the right arrow key and the left arrow key really fast when I move this jog controller. And the other ones are just mapped to spacebar and JKL, which work as those fast forward and rewind play buttons. So that's all that's happening on here is just translation of that MIDI data into something that the USB side, the software on the USB side wants to use. And I'm always tinkering around with this stuff. I think you know I've made a few different types of controllers. There's actually another one I'm thinking of making from scratch using the Raspberry Pi Pico microcontroller. But this was a fun one using sort of existing hardware. So I'm not adding NeoPixels to this. I'm not adding lots of extra rotary encoders and things. This is just what you see is what you get. But I'm able to now use this as one of my helpers for video editing. I used to use the Griffin PowerMate. I had 3 of those sort of rotary encoders and push encoders. Really nice, neat, but they're like 15 years old now. The software is not really supported, and I was always trying to sort of preserve some old software drivers to make things work, and it's just gotten to be too much of a pain. So I'm now on the quest for new video controllers. This also work in things like audio editing. You do sort of the same sorts of things, scrubbing your audio, setting marks, playing, rewinding, and so on. So this one, I believe, is using an optical encoder, which is why this is a very smooth, fluid wheel here that has quite precise, as you can see by my little hands moving there, has very precise control. So nice option instead of something like a typical rotary encoder, which is not going to spin on its own. This is essentially an optical encoder of some kind. So that's my little sort of in-progress project that I've been working on. And if you find this kind of stuff at yard sales or studios selling off old gear, grab it because it's built like a tank. Beautiful bent metal design for the case, and I think these are Cherry MX switches inside. And they come in a few flavors. There's the, I think they made some in USB, so you might have to do some USB hosting and intercepting of messages. Maybe it'll just straight up work. It's always a question with USB stuff. And then they had RS232 and the DIN5 MIDI, so there's a few flavors of those types of controllers. So that is my little project update. I think I showed this a couple years ago, and now I finally got it doing something, so I'm very excited about that. And I wanted to give thanks and credit where credit's due to Kevin J. Walters and C. Grover, who both created software that was usable for sniffing the UART MIDI, and that spits out everything from sysx messages to CC to clock stuff, I believe, and being able to look at that data coming in, getting turned into usable, readable, human-readable stuff, allowed me to very quickly and easily then turn that into some USB HID stuff. So I think I'll leave it at that. But as I refine that, I'll show you the code that's running on that. But thank you again to Kevin and C. Grover for the help with that, and of course to Lady Ada for building that very cool MIDI Featherwing. In fact, I'll show you that one right here. One second. Let me pull that up. Let's see. If you look here, where are you? There it is. The Featherwing MIDI Featherwing kit, $6.95. It has all that you need to plug in and read classic MIDI stuff and then do with it what you want. And this is all running in CircuitPython. You could also use Arduino if you want to. I keep hoping that there's going to be some make code MIDI progress made. There's some stuff that was done a few years ago, but it has not been fully developed yet, I think, but one day. All right. So thanks for your help with that. C. Grover said, yeah, I love that MIDI Featherwing. He says, yes. Very cool design. All right. And let's see, the last thing I want to do is talk about, as you can see here from the title, Pico Robot Demo Board Planning. So what does that mean? What's up? So we, in the past, when we came out with the Cricket, which is our robotics platform that you can plug Feather into. There's a different one you can plug Circuit Playground Express into. There's one for Microbit, and there's one for Raspberry Pi, I believe. One of the things we did when we came out with that is we built some guides on the basics of using different robot components, such as stepper motors, solenoids, servo motors, DC motors, and sound, and a few other things, with the intention of giving very nice chunks of fundamental, how do I do this thing on this platform? And so Lady Ada asked me the other day, hey, would you do a similar sort of thing for the Raspberry Pi Pico microcontroller, the RP2040 based microcontroller, without worrying about, there's no Cricket for it or anything like that, I'm not starting any rumors, but instead just using breakout boards and H-bridge drivers and MOSFET diode for solenoid, so that we can power a bunch of different things from a Pico. So I've just gotten started. Let me switch back over to the bench cam here, and I'll move this stuff out of the way. So I've just gotten started with some of the planning around that, but I also wanted to kind of open it up for any suggestions that people have on ways to make this fun and easy and accessible to use. So one of the ideas is to start off with just sort of breadboarding stuff. So I've got my Raspberry Pi here that I added. This is the Pico, Raspberry Pi Pico microcontroller, not single board computer, that I added my fancy breakout to so that we can see the pin names on it. So using something like that and putting this on a breadboard and then running the different breakouts so that we can use maybe a couple knobs and buttons to control some things, a stepper motor of some kind, maybe a 5-volt stuff instead of 12 volts. So I've got these little steppers here, servo motor, what else have I got? Solenoids. And what we did in the past was we mounted this all on just a big cardboard board. But one idea I had about this is trying to make it a little more modular and maybe find something like some small cardboard boxes, or I've always been a fan of building stuff into cigar boxes. So you can usually get these for very cheap at a tobacco store, or you may just have piles of these laying around. But something that makes a good, easy project box that's made out of either thin wood like these, or cardboard, or plastic, Tupperware container, something where we can mount maybe the breadboard and the microcontroller to one of them, and then run wiring to something that would be like a little NeoPixel playground, and something that would be a little motor board, little set of motors, something that's the servos. So if you have ideas about that, let me know in the chat. I'll be building that over this coming week, and hopefully I'll have something that we can play around with next week, as well as look at code for it. Planning on doing it in CircuitPython on the Pico. Right now we don't have rotary I/O, so I'll probably use a potentiometer rather than a rotary encoder to do things like move a servo or set the speed and direction of the motor. So this will be a fun little exploration, and idea is to mimic some of the stuff that Dano Wall and Ann Barella did with the Cricket project. So go take a look at that if you're kind of curious about where we're heading with this. Could be something built onto Legos, could be something built into other recyclables. So let me know what you think in the chat. I'll be hanging out there. And I just wanted to give you a sort of little preview of where I'm going with that. And we've come up with some ideas for which stepper driver we're going to use for that. This is a good little 5-volt stepper that'd be fun to drive from that. Here's maybe a simple little NeoPixel strip that'll plug in. Some ideas for maybe some of our little colorful buttons or arcade buttons. So that's where I'm heading with that, and I think it'll make for a good educational tool, as well as something that people can point to when the question comes up, hey, but how do I deal with, I just want to use a servo motor on the Pico. How do I do that? I just want to use a stepper on the Pico. I just want to use an electromagnet. So those will be some of the sorts of things that we do, very similar to stuff you may remember from the Cricket platform. But we're going to do it with individual chips and breakout components and the Pico. So that's just sort of a idea of where this is headed. And I'll have more to show you next week. Didn't have the time to get enough parts ordered and built in time for this week, so I'm just in the planning phases of it. Let's see. Oh, Blitz City DIY says that sounds really fun. Thank you. Here, let's pop up the chat. And capacitive touch, C. Grover. Good point. Yeah. So put a. I think there's some capacitive touch on the Pico, right? I don't know if we have that. Does anyone know? Do we have the cap touch working on the Pico and CircuitPython yet? I don't know what that board has for capacitive touch. That's a really good question. DRV8871 is a great motor driver for this kind of simple project. Thank you, 2231 Puppy. I'll have a look at that. Music-controlled robot, FX Music. You know, you're speaking my language. I love that idea. All right, good. Toddbot says, how about add a squirt gun to the RP2040? I love that. I love getting... Squirt guns are just DC motors, so if you can click them on and off with a transistor or a relay, you're good to go. And very safe. It's good to get water on your electronics. Always good idea. Thanks, Todd. All right, thanks everyone. That's going to do it for today, and I'll be hanging out in the chat. So if you have more thoughts or ideas or questions, please let me know. And I think that's it. Yeah, that's all I wanted to cover today. All right, thanks everyone. I will see you next time. That's it for today's John Parks Workshop. Bye-bye.